net changing theorem, right? So, well, this one is not something new. That's exactly the same thing with the fundamental theory of calculus part 2, right? But as long as you understand the relation between capital F and capital F prime, that's it, right? So F prime, like capital F is antiderivative of capital F prime, okay? Then that's exactly the same thing with fundamental theory of calculus part 2, right? And that's it, right? So now let me give you the example, okay? Here we go. So now we will talk about the particle moving along the line, okay? But look at that. Given function is velocity, okay? So now I can tell you like a really important concept. Displacement and total distance traveled, okay? So what is different between that? It's easy. Like, I'm here, okay? So let's say this direction is positive, okay? I'm gonna move like 1 unit to the positive and 1 unit to the negative, okay? Then where am I? I'm just like come back to my origin place, right? So this is displacement, okay? My displacement for this moving is 0 because I came back to the original point, right? But what about my distance traveled, total traveled distance? It is 1 unit and one another unit, which is 2. Does it make sense? So let me summarize everything on this side, okay? Then everything will be clear. Okay, here we go. Important note. Okay, if you want to calculate the displacement, that is just simple integral from a to b with the function dx, right? Which means like added part and subtracted part. Then like subtracted part must be negative, okay? It is like basically this calculation, okay? But if I ask you to find total traveled distance, okay? Let's say the total, okay? It is equal to integral a to b, but for this case, you must have the absolute value. Why? As I showed you, go forward, that is fine, okay? Because there's go forward, which means it will be added, okay? But backward, even if it is negative value, you have to add as the distance, right? That's why you have to have the absolute value, okay? So now, let me try to apply these two things in this problem, okay? I have velocity, then integral value of the velocity function is the distance, okay? So like the first problem asks you to find displacement, right? Then it's really easy, right? It is integral 1 to 4 with a given function which is t squared minus t minus 6 dt. Let me keep the parentheses here, okay? And that's it. We can evaluate this, right? It is equal to 1/3 t cubed minus 1/2 t squared and minus 6t, and we're gonna plug in 1 and 4. Okay, plug in 4 first. 1/3 4 cubed 4 squared 4 and minus, plug in 1 now. 1/3. I don't have enough space. Let me make it smaller a little bit. That's it. And then let me block this guy on the side, okay? So are you with me so far? Then now, here we go. 4 cubed is 64 over 3 and minus 16 over 2, 24, and then minus 1/3 minus 1/2 minus 6. Then it is equal to minus 9 over 2. Let me skip about this calculation, okay? And what about next part? Now I ask you to find the total traveled distance, right? So as I told you, it will be done by integral 1 to 4, but it must be absolute value of your function t squared minus t minus 6 and dt, right? To complete this one, we would like to know the graph of this function, right? So here we go. So let me give you this graph of this one. It is definitely a smiley face parabola, right? And then your intercepts are, since this is t plus 2 and t minus 3, and negative 2 and 3s are the x-intercepts, right? -2 and 3. So this is your graph. But we would like to talk about 1 to 4, right? So it will be 1 is somewhere here, and 4 is somewhere here. So can you see this guy? There are 2 parts, right? 1 to 3 is negative, and 3 to 4 is positive. Is that okay? So like to take care of this absolute value, then we're going to make negative part as positive and positive part as positive, right? So to make a negative part positive, we're going to split this like interval of the 1 to 4 to the like 2 part, 1 to 3 and 3 to 4, right? So integral 1 to 3 is just upside down, which means negative function. Is that okay? And then 3 to 4 was positive, so we're going to keep it. As positive. That's it. Okay? That's it. So now we have to evaluate this guy and this guy separately, okay? So let's do it. So it is equal to, by the fundamental theorem of calculus part 2, -1/3 t cubed, I just distribute like this negative into there, okay? Now it is positive 1/2 t squared and plus 6t, and we're going to plug in 1 and 3, okay? And second part, plus similar, but like it is similar, but it's different, right? 1/3, it might be better to use the parentheses for whole this thing, right? And then parentheses here, 1/3 t cubed minus 1/2 t squared minus 6t, and plug in 3 to 4 for this case, right? Then just algebra, right? Plug in 3 first and plug in 1 and subtract, right? It is equal to 3 -1/3 3 cubed plus 1/2 3 squared plus 6 3, the first one, and minus, plug in 1, -1/3 1 cubed 1/2 1 squared 6 and 1, not this parenthesis bracket, but just parenthesis, okay? That's it for the first part, okay? What about second part? Plus, plug in 4 first. 1/3 4 cubed minus 1/2 4 squared minus 6 and 4, and then minus the very last part, plug in 3 in there, 1/3 3 cubed minus 1/2 3 squared minus 6 times 3. That's it. Okay,